Hi guys and welcome back. In this video we're going to learn about pack. Pack, you can think of it as putting the components in the window where they fit, given that they adhere to certain constraints that we give it. Pack can be a little bit confusing and a little bit unpredictable at times. This is why in this video we're going to explain how pack behaves by giving you many examples. Let's start by creating a couple of labels. And here I'm using TK labels as opposed to TTK labels, just because we don't need the themed or the styling of those labels at this point. So we're going to put two labels in the root. Okay, here we have two labels and we have placed them in the root. Now, if you remember correctly, whenever you run a code like this, you won't get anything in your window because you've not packed the components into it or you have not placed them. I'll say at this point that as well as pack, there are other algorithms for placing components in the container, but we're only learning about pack in this course. Let's give these labels some text. So I'll say label 1 and some background, which will be green. And the other one is going to be text equal label 2, and the background is going to be red. Then we're going to pack them. So the first one we will pack on the left, and the second one we will pack on the top. Let's run this here. You can see that they appear side by side, even though one has been packed on the left and the other one has been packed on the top. So what does side mean? Well, you can think of side as the anchor point to the component. And what that means is that this component, label 1, is glued to the previous component or the window by the left side of it. By contrast, label 2 is glued to the window on the top and not on the left. You can see that that happens as you expand the window. The label 2 keeps being stuck at the top, but label 1 is stuck on the left. As the space expands, label 1 has no knowledge of vertical distance because it is glued on the left, so it always stays in the middle. And label 2 has no knowledge of vertical distance, so it stays on the left, as close to where it originally appeared as possible. Next up, let's use fill. So we will say fill equal y and fill equal x. Let's run this again. And now look at what happens. We have filled on the y-axis the left label. And that means that it now takes up as much vertical space as is available. So the background and indeed the entire label spans the whole vertical space. Similarly, label 2 spans the whole horizontal space, or as much as is available, but there is a gap here where the green label is. Because the green label was added first, it takes priority. So it fills on the y-axis first before label 2 has a chance to expand. If we do the other way round, putting label 2 first, then you'll see what I mean. So now label 2 is glued at the top, label 1 is on the left. As we expand this, you can see that label 2 now takes up the entire area because it takes priority. It was put in there first. Let's go back to this. Instead of x and y, we can do both. And here is where it starts to get interesting. So we've got both of these labels here, and as we expand, you'll see that nothing happens that is different from what we had before. That is because even though these labels have a fill that tells them to take up all the available space on both x and y, there is no available space on x and y. This label here only takes up this much space horizontally, and this label here only takes up this much space vertically. That comes to mean that you can only fill a label cross-axis. So if it has been if it has a side of top, then you can fill it in X. And if it has a side of left, you can fill it in Y. Unless you use expand, and we're going to learn about that in just a moment. Now, if you remove fill both from one of them, then this is what happens. The label stays in the middle of the axis that you told it to. It doesn't have any knowledge of the vertical spacing, and indeed it doesn't take up that space. However, the space is still reserved for it, so this label cannot span into that. Now, let's use expand. So we'll do fill equal both and expand equal true in just the one label to show you what happens. Now that we've got expand equal true, what that does is it requests from the container as much space as possible so that the other containers don't shrink past the minimum content width. So this is a little bit confusing, but essentially label 2 still gets to keep the space it needs to show its text. Label 1 takes up all the other space. And because it has fill of both, then it takes up the entire space there. Notice that if we say fill only on Y here, now this label is still taking up all of the space, but the component itself is only taking up as much of the Y space as possible. The rest of the space is still reserved for it, but it is not being used. Next up, let's make both labels side top and both labels with fill both and expand true. Now what happens is that both labels are stuck to the top of the previous element. So label 1 is stuck to the top of the container, label 2 is stuck to the top of label 1. And in both cases, they're going to take up as much room as possible, and they are both requesting all of the space. In that case, it gets shared 50-50, so both labels will fill in the y-axis as they would normally because side is top, and both labels grow on the x-axis because they both have expand equal true. Whichever side comes first gets the expansion priority. We mentioned this earlier briefly, but let's create another label in the root with text of label left, and the background is going to be green, and we're going to pack it on the left with expand equal true and fill of both. Now these other labels are going to stay on top with fill both and expand true. And I'm going to make this one red as well. So if we do this and we press play, you'll see that the side of left gets the expansion priority and takes up all of the horizontal space. And these labels here are only taking up vertical space. That is because they have a different side and they were placed afterwards. If you do it the other way around, you'll see that now the opposite happens. These labels take up all the horizontal and vertical space, and this one is left with basically nothing. I would recommend that you play around with a lot of these different examples. It took me a long time to fully understand what's going on with these before moving on. Finally, something worth mentioning in this example is that even though this label has a side of left, it still appeared underneath these other labels. And that is because when you anchor a label and give side of top, it takes up the whole vertical space available. Anything after it will appear underneath it. Similarly, when you give a side of left, it takes up all the vertical space, and the next element will appear on its right. So this is what happens when the first element has a side of top. And again, going back to the previous example, if you have a side of left first, this element takes up the entire vertical space and all future elements appear on the right. So this element took up the entire vertical space, the next label appears on the right, and it takes up the whole horizontal space, so the next label appears underneath it. So this one has also taken up the whole horizontal space. So if we have another label top, it will also appear underneath it stacked. But what happens if we add another left? Well, because the previous label has a top, this one also appears underneath. So the label itself's side is irrelevant where it is placed. What matters is what previous elements had as their sides. Okay, so now if we put another left, given that this previous one has a side of left, you'll see that it appears here. So this one took up all the vertical space, then this one took up all the horizontal space, then this one takes up all the horizontal space, then this one takes up all the vertical space that's remaining, and this one appears next beside it, since there is no more vertical space to go around. So as you mix and match these spaces, essentially the distribution changes, but what matters is what the previous element had as their side. If the previous element had a side of left or right, if it has one of those two, then that takes up the whole vertical space. And if it has a side of top or bottom, it takes up the whole horizontal space. And the next element will appear accordingly. Please, again, do play around with these. Play around with expand, fill X, fill Y, and with different configurations of these labels to really grasp how Pack works. And if you have any code snippets that you don't understand how they work, do put them in the course Q&A, and we will be more than glad to help you understand them. Thanks for joining me in this video. Hope it's been interesting and you learned something, and I'll see you on the next one.